Imagine this. You're scrolling through your phone when suddenly everything goes dark. WhatsApp stops working. Your UPI payments freeze. Google Maps vanishes. No internet, no communication. Complete digital blackout. Is it a cyber attack? A declaration of war? No. It's something far more powerful, and it's already happening. In the past 24 hours alone, our sun has unleashed 17 major explosions. Right now, a massive sunspot, larger than Earth itself, is aimed directly at our planet. Scientists are tracking extreme solar activity that could disrupt our entire technological infrastructure within hours. The question isn't if this will affect us. The question is, are we prepared? I'm Bhuvan from Study IQ, and today we're diving deep into the science of solar storms, geomagnetic disruptions, and what recent solar activity means for Earth. Before we discuss the current threat, we need to understand what makes our sun such a volatile, unpredictable force. The sun's anatomy. At the core of our sun, temperatures reach approximately 15 million degrees Celsius. Here, nuclear fusion continuously converts hydrogen into helium, releasing tremendous amounts of energy. But what makes the sun particularly dynamic is its composition. Plasma. Most of us learned about three fundamental states of matter in school: solid, liquid, and gas. However, there's a fourth state, plasma, and a fifth known as Bose-Einstein condensate. For our purposes today, plasma is what matters. What is plasma? It's an electrically charged, superheated gas consisting of free-moving ions and electrons. The sun is essentially a massive sphere of churning plasma, constantly in motion from its core to its surface and back again. Critical solar processes. The sun doesn't rotate uniformly. Its equatorial region completes one rotation in approximately 25 days, while the polar regions take around 35 days. This differential rotation, combined with massive convection currents, creates what scientists call the solar dynamo effect. Convection currents work like this. Hot plasma rises from the core through various layers: the photosphere, chromosphere, and corona. As it rises and cools, its density increases, causing it to sink back down. Once it descends, it heats up again and rises. This continuous cycle creates powerful magnetic fields that twist, turn, and occasionally snap, releasing catastrophic amounts of energy into space. Sunspots, the birthplace of solar storms. NASA scientists have confirmed that a massive sunspot is currently facing Earth. But what exactly are sunspots? Defining sunspots. Sunspots are cooler regions on the sun's surface. Though cooler is relative, they're still around 3,800 Gromoscos compared to the surrounding 5,500 degrees C. They appear as dark patches because they're areas where cooler plasma is descending back into the solar interior. More importantly, sunspots are regions of intense magnetic activity. They're the launch points for solar storms, violent eruptions that hurl plasma and radiation toward Earth at extraordinary speeds. Think of sunspots as pressure valves. When magnetic field lines become too twisted and stressed, they snap, releasing energy equivalent to billions of nuclear bombs. When plasma erupts from a sunspot, it travels through space as a coronal mass ejection, CME, or solar flare. Fortunately, Earth has a defense mechanism, our magnetic field, generated by the movement of molten iron in our planet's outer core. This magnetic shield deflects most charged particles. However, it's not perfect. The magnetosphere has a kidney bean shape with weak points near the poles. When solar plasma penetrates these regions, it interacts with atmospheric gases, causing them to glow, creating the spectacular light displays we call auroras, Aurora borealis in the north, Aurora australis in the south. But auroras are just the visible effect. The real danger lies in what we can't see, the solar cycle. Why now? To understand why solar activity is intensifying right now, we need to examine the 11-year solar cycle. The sun follows a predictable pattern of activity. Every 11 years, it transitions from a quiet period, solar minimum, to an active period, solar maximum, and back again. During this cycle, the sun's magnetic north and south poles actually flip. At solar minimum, sunspot activity is low. The sun is relatively calm. But as we approach solar maximum, sunspot numbers increase dramatically, and the likelihood of powerful solar storms skyrockets. The last solar maximum occurred in 2014. Adding 11 years brings us to 2025, 2026. Right now, we are currently in the peak phase of solar cycle 25, which explains the recent surge in solar activity. This isn't the first time we've discussed solar storms this year, and it won't be the last. October saw significant solar activity, and we're now experiencing another wave of intense solar eruptions, classifying solar flares, the X-class threat. Not all solar flares are created equal. Scientists classify them based on their strength. A class: barely noticeable, minimal impact B class, minor effects. C class: small flares with localized impacts. M class: medium flares that can cause brief radio blackouts. X class: the most powerful flares capable of causing widespread disruptions. Each class is 10 times more powerful than the previous one. Within the X class, the scale continues, X1, X2, X3, etc., with no upper limit. The recent eruptions on February 1st and 2nd, 2025, included an X-class solar flare, among the most powerful the Sun can produce. The effects of this eruption are expected to reach Earth around February 4th and 5th. Real-world impacts. What happens? When solar storms hit? Earth. Let's be clear, solar flares don't cause forest fires or tsunamis. They don't directly increase temperatures. So what do? Technological disruption. When electrically charged plasma from the Sun slams into Earth's magnetosphere, several critical systems are affected. Satellite disruption low Earth orbit satellites can be pushed off course or damaged by intense radiation. GPS systems become unreliable, affecting everything from navigation apps to aviation systems. Power grid failures. Geomagnetic storms induce electrical currents in power lines, potentially overloading transformers and causing widespread blackouts. The 1989 Quebec blackout, caused by a solar storm, left 6 million people without power for 9 hours. Communication. Breakdowns. Radio communications, especially high-frequency systems used by aviation and maritime industries, can be severely disrupted or completely knocked offline. 4. Financial systems. Modern financial markets rely on precise timing systems synchronized by GPS. When GPS fails, high-frequency trading and banking operations can malfunction. Increased radiation. Exposure airline crews and passengers on polar routes receive higher doses of radiation during solar storms, equivalent to multiple chest X-rays. Despite the risks, there's one beautiful consequence: enhanced aurora visibility. Last year, during the previous solar maximum phase, auroras were visible as far south as Ladakh, India, an extremely rare occurrence. With the current X-class solar flare, there's a high probability that residents and travelers in Ladakh will witness spectacular aurora displays in the coming days. If you've ever wanted to see the northern lights without traveling to Scandinavia or Iceland, this is your chance. The next solar maximum won't occur until 2036. Solar storms are not a matter of if, but when. As our civilization becomes increasingly dependent on technology, our vulnerability to space weather grows. While we cannot control the sun, we can improve space weather forecasting, harden critical infrastructure against electromagnetic pulses, develop backup systems for essential services, educate the public about risks and preparedness. The recent solar activity serves as a reminder. We live in a dynamic solar system, and Earth is not isolated from cosmic forces. As always, you can download the complete PDF of this discussion on my Telegram channel, Bhuvan Study IQ. If you're a civil services aspirant, you'll find current affairs articles, topic-wise MCQs, and monthly compilations, all free of cost. Your feedback, suggestions, and comments are invaluable.